welcome to Atega Tech Academy. Today we'll be looking at how to calculate impedance and series RLC circuits. So please, without wasting my time, I would like you to like, subscribe and share the videos to your colleagues. Okay, so today we'll be looking at impedance. How do we calculate impedance? So we say impedance is the opposition to current flow in AC circuit due to the presence of resistive, inductive and capacitive elements. And the opposition due to inductive elements is called reactance, so we call it XL. So reactance is represented as XL, and the opposition due to capacitive elements is called capacitance. And we can represent inductance as XL, which is equals to omega L, and omega L is equals to 2 pi F. So it becomes 2 pi L. You can represent it as this. Now we represent capacitance as 1 over omega C. So here it can also be equals to 1 over 2 pi Fc. So these are the two notations on how you can represent your inductance and your capacitance. Let us now look at a circuit that has a resistor, an inductor and a capacitor in it. Realize that in our unit 1 we were calculating total resistance. They always ask us to calculate total resistance, but here they'll be asking us to calculate impedance. Why are they saying we should calculate impedance? Because impedance is a mixture of both capacitance, resistance and inductance. So when any of these two are in a circuit, we don't call it resistance, we now call it impedance. So you realize that this circuit here, we have your resistor, you have your inductor and you have your capacitor. So how do you now calculate it? So to calculate your impedance is you simply add everything here and square them. So this is the formula we use to calculate it. So our Z here is equals to the square root of R squared, that is the resistor square, plus our inductance minus our capacitance square. So this is how we simply calculate our uh, our impedance in an RLC circuit. So let's say if it was only an RC circuit, so if let's say for RC circuit, RC comma Z would have been equals to, because we don't have this thing, sorry, if it was an RL circuit, Z would have been equals to R square plus XL square, all square root, because we don't have a capacitor here. So if it was an RC circuit too, you do the same, because you would not have an inductor there. So that is how we simply do it. And to also calculate for the phase between the two angles, you can calculate the phase by using the formula tan theta is equals to tan inverse of the inductance minus the capacitance all over the resistance. So this is how we calculate the angle between the impedance. So these are the useful formulas we need for our calculation. So without wasting much time, I want to take our first example, then we'll see how it goes. Okay, we are given our first question and they are saying we should find the a coil has R is equals to 12 ohm and inductor is equals to 0.1. It is connected across a 10 volt 50 hertz supply. Calculate the reactance and the impedance of the coil. How do we calculate the inductance? So to calculate the inductance, we simply inductance XL is equals to 2 pi FL. So it simply equals to the 2 pi, and our frequency is 50 and our inductance is 0.1. So we just multiply it by the 2 pi by the frequency and the inductance, and we are having 31.416 ohm. Then we need to now calculate the impedance. To calculate the impedance, we said impedance Z was equals to R square root of R square plus XL. This is our XL, so, and our R was 12, so we just square it. So R square plus XL, which is equals to 12 square plus this, and we'll get our final answer as this. And this B says we should calculate the current. So calculating the current, we know that from Ohm's law, V is equal to IR, and here we know that since it's now in a combination of resistors and capacitors and inductors, it now becomes impedance. So our V is now equals to IZ. So calculating that, our I here will now be equal to V over Z, and our Z was 33.63, so our V was 100. So we simply divide our 100 by our 33.63 to get 2.97 amps. And the last one says the phase difference or angle between the current and the applied voltage. So the angle was equals to, our theta should be equals to the tan inverse of XL all over R. So since we have only XL here, it now becomes, the phase difference now XL all over R. So doing that, we get our final answer as 69.09. This is how we simply calculate the angles and all the values needed. Thank you. Okay, our question says, problem 2 says, a resistor R is equals to 40 ohms is connected to a 230 volt 50 hertz supply. The 50 hertz is the frequency. And A, what is the peak value? B, the current flowing and the power dissipated in the resistance. So let us tackle them one by one. So how do we calculate for the peak value? So to calculate for the peak value, that is, we know the VRMS value. So finding the peak value should be equals to the VRMS value here is the 230 volts. And since it's the 230 volts, we just multiply it by root 2 to get the peak value. So multiplying it by root 2, VRMS by root 2, we'll get our peak value as 352.256 volts. And after doing that, they said the current flowing and the power dissipated in the resistance. So doing that, to calculate the power flowing, power is equals to the current flowing. So the current flowing, how do we calculate current? Current is equals to IR. So finding the current, we divide the voltage by the resistance. So the voltage was 230 volts and the resistance value was 4. So dividing it, we have our current as 5.7 amps. And we need to now calculate the power. We know that power is equals to, we have so many powers, but so many formulas for calculating powers. Power is equals to I squared times R. So using that formula, the I squared, we know the current times the resistance. So 5.75 squared times 40, which is equals to this in watts. If I want to leave it in kilowatts, I will leave it as this. Then after doing that, they said a conductor, if an inductor L 50 millihenry, that is 50 times 10 raised to the power minus 3, is added in series to the circuit, what is the total impedance in rectangular form and polar coordinate? So here we need to calculate the impedance in both rectangular form and polar coordinates. So doing that, we have to redraw the circuit. So this is our 50, drawing our circuit. They said the resistor was in series with a 50 millihenry. So this is the resistor, this is the 50 millihenry inductor. So what is the total impedance? How do we calculate for the impedance? So Z is equals to the square root of the R square plus the 40 square plus the 50 millihenry square. So doing that, to find our impedance, this square, the R square plus XL square, we do that, but we know that XL is equals to 2 pi FL. So converting it back, the 50 milli is simply 10 times 50 times 10 raised to the power minus 3. Doing that, we have our XL as 15.70 ohm. Then putting it back into our equation, we now get our final answer as 42.973 ohms. So our impedance becomes 42.973 ohms. And they said we should calculate the impedance in rectangular and polar coordinate. We now need to find the angle. How do we find the angle? This is the polar coordinate. So to convert it to the polar coordinate, rectangle is R plus JXL. Because why is it the resistance? This is what you have to keep in mind. With the resistance, whenever you are calculating a question, the resistance side is always the cos side, or let me say the X component. Starting from the inductor and the inductor and capacitor are always the the complex component. That is where you add the j. So doing that, we had our answer as this was our answer. So we have the 40 plus the j, which was 15.70. So this is the rectangular component. And changing it into the polar coordinate. So changing it, so we just find the angle. How do we find the angle? We find the angle by dividing theta is equals to the tan inverse of the 40 divided by 15.70 divided by 40. Then we'll get our angle of 21.43. So this is how we simply get our angle. And they said, what is the current in the AC? What is the current in the AC? So now, how do we calculate the current in the AC? So calculating the current is equals to the VRL, that is VRL, the voltage in the RL circuit, divided by the impedance in the RL circuit. So what was the voltage in the RL circuit? The voltage in the RL circuit was 230 angle 0, because we didn't know the phase. And what was the impedance in the RL circuit? The impedance was 42.973 angle 21.43. So doing that, we get our answer as 5.35 angle minus 21.43. Then that becomes our current. And they said, what is the power dissipated? So here, to find the power dissipated to is simply the current square times our resistance. So finding the power, we simply multiply the current and the resistance. So the current here is 5.35 times square times our resistance, and we have our power as 114.9 watts. So this is how we simply calculate all the components you will need. So kindly take your time, go through it, and you will be fine. Okay, so problem 3 says which an RL circuit is connected to a 230 volt 75 hertz with a rating of 750 VA. If the resistor is 40 ohm, what is the value of the inductive resistance, reactance, and the inductance? So here we realize that this 750 VA is the apparent power, that is the S. We said apparent power was represented as S, and the 75 is the frequency, and it's an RL circuit. So we have to use the apparent power formula. So S is equals to IV. So first of all, finding the inductive reactance XL. So the XL is equal to 2 pi FL. So that is the formula. But we need to now first of all use this formula. We know that apparent power is given, S is equal to VI. And since we know S, we know V too. So we have to make I the subject. Making I the subject, I now becomes V over S. Then we get our current flowing through the circuit as 3.26 amp. After getting the current, we now have to calculate the impedance. To calculate the impedance, because we know the resistance already, and we can now calculate our impedance. So doing that, we quote our impedance formula, z squared, this whole formula. Then they said we should calculate inductance. We make inductance the subject. Making inductance the subject now becomes z squared minus r squared, all square root. So we have to find impedance, and since we already know the value of r, we now need to find impedance. How do we calculate impedance? We know that V was equals to Iz. So what do we know? We know I and we know V. So we just need to make Z the subject. Making Z the subject, we get Z is equals to 230 all over 3.261 divided by, which is equals to 70.531 ohms. So we now know our impedance and we know our resistance. So we now simply subtract our impedance from our resistance and just square root it. So doing that, we get our impedance, our XL as this. So we just change the values. We know this was Z and we changed it here. This was R. R was 40. Then we change it back. So doing that, and we get our XL, our capacity, our inductance as 58.091 ohms. And now we need to calculate the value of the inductor. So we've now calculated the inductive reactance. So we now need to calculate the inductance, the L. So calculating the inductance, we knew that XL was equal to 2 pi FL. So we simply need to make this small l the subject. So making this small l the subject is simply equals to our XL divided by 2 pi F. We know the frequency already. Frequency was 75. And we just divide the 58.091 divided by 2 pi times 75, and doing that we get 0.123 Henry, and we can leave it in millihenry as 0.123 millihenry. So this is how we simply calculate the inductive reactance and the reactance of a circuit. So maybe in a question they might change it. The next time you might be seeing a capacitance, so you simply also use the the capacitance formula. So this is how we simply calculate it. So please don't forget to like, share, and subscribe for more content. Please kindly leave a comment, kindly like, kindly subscribe. It really goes a long way to really help us to know that you are liking our content or not. So please, and if you have any issues, feel free to contact us. You can email us. You can also contact us directly with our phone lines. We also have a Telegram channel that you can join so that you can make good use of these resources. So I hope these ones help you to understand RLC circuit very well. Have a nice day. Take good care of yourself. Please, I'm signing out.